Now, welcome again, and you can see a different problem on the screen. This problem heading is magnetism, but this is again the electromagnetic induction phenomenon. And we are about to solve it. You are very much familiar with this kind of problems because IITs have already asked it several times, and there are textbooks filled of problems like this. But this problem is a bit different. It needs a different analysis. The problem is at your screen, you can read it. Two metal rods AB in front. I have to take it in mind. Take it in my mind. And CD can move without friction. So friction is absent. You don't need to worry about it. Along two horizontal parallel rails separated by a distance L. This distance is L. A rod has a mass M and a resistance R. That means every rod has a mass M and a resistance R. So we have all together 2R resistance to R. A uniform magnetic field B is perpendicular to the plane of the rails. This is out of the screen, perpendicular to the screen like this. This is the magnetic field present in the region. And initially the rods are perpendicular to the rails, of course, and are separated by a distance d that you can see here. The rod CD is at rest, so it starts its journey from the rest, and the rod AB is given an initial velocity V0. That's also good, which is parallel to the rails, of course. Why not take this x-axis? Sorry. X-axis. Take your y-axis, perpendicular to x-axis, but within the plane. And z-axis, just outside, normal to this plane. So that magnetic field is in z-axis, and the velocity v0 is towards the x-axis. How far will the rods be after a long time? That means t tends to infinity. I think infinity comes earlier nowadays. So how far away will be the rods after a long time, okay? And how much heat will be produced by the system? Neglect the resistance of the rails. This is a good line. I really like this line. So what happens that everything in this setup, everything looks fine. And I guess the trouble starts from here when the rod AB is given a velocity V0 towards right, that is our x-axis. So, and it is still at rest. That means whenever we provide this rod a velocity in a magnetic field, it will start acting like a EMF source, a battery. Its source has been changed. It has now been converted into a battery. Why? Because the electrons within this rod is definitely made of metals, and metals, have lots of free electrons. So any free electrons, whatever it is doing, it will be imposed an extra velocity of V0 if the rod is moved in this way. And the electron in turn is bound to experience a magnetic force that would be minus EB cross B. Minus E is the charge of the electron, and V is the velocity vector, V cross B, and V is the magnetic vector. And we can write here at this very first moment at t equals 0, v naught I cap cross magnetic field is B and in the direction of z axis, so this force will start acting on it. And to contain the minus sign, I am going to treat it like k cross I, and that will be j. So what we call that E V naught B force is going to be experienced by an individual electron along the z axis. That means it will start drifting or towards end A. So this end will become negative and this end will become positive. And as you know, this phenomena will be resultant to produce an electric field because this negative charge accumulating at end A will make it negatively charged and that is going to produce negative potential and this will produce positive potential. So potential difference has been created along the length of the rod. That means an electric field will act from higher potential to lower potential in this direction. And finally, what happens in nature, the electric field and magnetic field both will start acting on every individual electron and they will produce a dynamic equilibrium in which the forces on any individual electron, the electric and magnetic forces, will become equal to each other. And this wire becomes a battery, negative end here and positive end here. So it will act like a battery like this. And this battery, this source of EMF is going to produce a current in the loop. Can you see the loop? In this direction, in anti-clockwise direction. No, sorry. This battery will produce current in this direction, clockwise direction. Okay, sorry. Current moves in a battery outside from battery to higher potential to lower potential. But inside the battery, what I'm talking about. This battery is going to produce a current in this direction. That's correct. It drives the current in this direction. And am I right or not? Am I confused? No, I can't be. Let's analyze it in a different way. This area will increase if it goes towards right. The area will increase. That means more flux of this magnetic field. This magnetic field will come out from the loop now. And loop has a tendency to oppose this increase in flux. So it is going to produce a magnetic field in this direction, opposite to the existing magnetic field. So to produce the magnetic field inside this plane, you will need a current in clockwise direction. Current in this direction, name it I, will start flowing. And current in this direction will start flowing. That means this current will pass like this. In this direction through this rod CD and in this direction from this wire AB and a current in a magnetic field. Something like that. How do we change it? A current in the magnetic field is going to attract an ampere force IL cross B. So what IL cross B on CD we are going to see? This L is its length, and we need to treat this like a vector, so I am going to give it a unit vector J, because direction of this length vector will be in the direction of the current passing through it. So IL cross B, and B is this magnetic field, this intelligent magnetic field, and this is K. So this is J cross K, that means this will become ILB. J cross K is I in this direction. So a force will start acting on it. Force, magnetic force. Why should not we write this Fm? Force, magnetic force will start acting on this CD. So it will start moving in this direction because there is no friction. It has been placed on a smooth horizontal radial. So it will start moving in this direction. It will going to have some kind of velocity. I don't know how much it will have some velocity, and I think this Fm will also going to act on this rod AB. So the current is in opposite direction, so magnetic force will change in this direction. So we have given it initial velocity in this direction and the force in this direction. That means हम किसी को आगे बढ़ा के उसकी टांग खींच रहे हैं. We are pulling the leg by pushing it in front. So it will start decelerating and it will start accelerating. It will start accelerating with zero velocity, and it will keep losing its velocity V naught. When the cruise will happen, what will happen next? It will keep losing the velocity, it will keep gaining it, and everything vanishes. When both will have same velocity in this direction. When does it happen? I don't know. But whenever it happens, they attain same velocities. Because it is continuously losing this velocity V naught and it is continuously getting it. So it's bound to happen that they will attain equilibrium of some kind when their velocities will become same. Direction same, magnitude same, and then the flux, the EMF, the flux will stop changing. Area will become constant. Flux will stop changing, and EMF will vanish, and the current vanishes, and there is friction, and they have attained some velocity, they will keep moving forever. When does the rails are present there? The rails will form a path for them. So that is the question. What happens after a long time? So we are not going to find the time, but we can see the consequences. It is this thing is going to happen. So how can we solve this problem? How can we solve this problem? How much, suppose I'm going to remove everything from now, and going to get a new picture here. And what this new picture is, these are the rails, these are the rods, the names are AB, they are named CD, this length is L, and this length is D. At the moment, its initial velocity was V0. Now, This is decelerating, this is accelerating. It has become a battery like this, and it has become a battery. It will also become a battery like this. And if its velocity somewhere is VCD, and its velocity at any time t, I'm considering the conditions at any intermediate moment, not at t equals 0 exactly, because initial moment has been passed, now come to the battleground. And we have to discuss things after some time passed. Let's call it at time t, and then its velocity, I'm going to simply call it at that moment AB. They have not achieved the same velocity yet. This is an intermediate moment considered. This is an intermediate moment of their journey before they are going to make the cruise or achieve the equilibrium. So their velocities are different, so their EMFs will be different. And this EMF is VBL, we all know. So this will be B is the magnetic field and L is the length. Wow. And the EMF it is going to produce is VCDBL as well, right? And current is passing like this in this direction. So the net EMF is this EMF minus this EMF. Net EMF produced in this loop is net EMF produced in this loop is this VAB minus VCDBL. And the current, just named it I. At any intermediate moment, the current is capital I. I named it, nobody else did. I did it. So this current will be EMF produced in this loop divided by total resistance. They are in series. Total resistance is 2R because each wire has a resistance R. I know, and each wire has mass M. So the current passing through the loop is VAB minus VCD BL divided by 2R. This is the current passing through the loops, and they are experiencing two magnetic forces. This one is here, and magnetic forces will have same magnitude because I is same, B is same, and L is same. So they will have same. They are experiencing same magnetic forces. But this one in front is decelerating, and this one is accelerating. I have no option except to go and write the Newton's second law of motion for them. And Newton's second law of motion for AB, where AB is dVAB is intermediate time velocity, dVAB upon dt equals minus. Why minus? It is decelerating, and minus this force. What will be the magnitude of this magnetic force? ILB. I is here, LB. So magnetic force I can write here is I, that is VAB minus VCD BL divided by 2R IBL, B square L square. So this is rate of change of velocity. I would like to write in terms of force by mass. So force is here, and force is VAB minus VCD B square L square by 2R, and mass I can write here. So magnetic force, we have the magnetic force. I have removed it now. And for CD will be simply dVCD upon dt. It equals to force. It is accelerating, so the force will become VAB minus VCD B square L square upon 2 MR. Mr. RM. Oh, sorry. It is still fine. So we have two equations. Newton's second law of motion should always be given a number. I don't know whether it is looking on my screen or not. But if it is, these are the velocities. We can remove these things as well. We don't need this. Or I can do another thing as well. I forgot. But we have something like that. And the problem here is it was the picture at initial moment. And nobody knows what kind of velocity. The velocity is here, BAB and BCD, and the length is not x perhaps at this moment. Length is not d perhaps. D was at initial moment. Its length has become x now. X. So one thing is clear here. Here you can see from this picture. If you can see this picture, I've just got an equation to connect them. Got something in mind. Dx upon dt will be different definitely. BAB minus, this is kinematics, nothing else. BAB minus BCD. So this dx will be, this dx will be BAB minus BCD multiplied by dt. And if I place dt here, we will get something like that. We will get d BCD or B, start from BAB, first equation. DBB equals minus BAB minus BCD multiplied by dt. I can write here as dx, simply dx, and it will become B square L square by 2mr. Looks beautiful now, because I can do more of the things. DBB, not BB, this is BAB, sorry. So I should write something like that, that we have DBAB equals minus B square L square upon 2mr dx. And I can integrate them because nothing else I can do after getting a differential equation. And BAB, its velocity was V naught initially, and then now at this moment its velocity is BAB. And x was initially d, now it has become d plus delta d. I don't know what is the exact value of x, but initially it was given d. So I can write a moment later as d plus delta d, or something like that. We need to find only delta d, so I have got a result that is BAB minus V naught from left side equals minus B square L square upon 2mr. And this thing is delta d only, delta d. So we have one thing. We got something. BAB equals V naught minus B square L square upon 2mr delta d. We have our VAD. Now what? Now we can find VCD. And to find VCD, you should look at this equation. And this is accelerating, and its initial velocity was 0. So VCD, I can directly write as B square L square upon 2mr. This is our VCD. So I got the velocities of relation between velocities of both rods and the distance they have moved. We needed to find this delta D. I can do this. I can do this. Anyone can do this. Because after a long time, there will be truths. And VAB will be equal to VCD. and that means V naught minus B square L square upon 2 mr delta D equals B square L square upon 2 mr delta D, and that means V naught equals 2B square L square upon 2 mr delta D. 2 gets cancelled out, and the value of delta D I got here is V naught mr divided by B square L square. So the final distance between both rods will be D plus delta D. That is D plus V naught mr by B square L square. This is one of our answers. Now perhaps we needed to find out the velocities. The value of velocities, that means what will be the value of VAB and VCD at the moment when the cruise happened, when they come in equilibrium, everything is not going to change after. Oh well, I can do this. I can do this. Once I got the region, I can do this. These two equations. Yeah. Remove them up. You can do this. You can. Yeah. We can write it something like that. VAB equals V naught minus this whole thing is VCD. And when VAB is equal to VCD, we can always write VAB equals VCD. So VCD equals V naught minus VCD. So 2VCD equals V naught. That means VCD is going to be V naught by 2, and that will be the value of VAB. So finally, they are going to have velocities like V naught by 2 or V naught by 2 each. The world is beautiful. Good. Too many symmetries. So their velocity will become V naught by 2. Okay. So now there is one more thing. The heat evolved in the whole total process. Why the heat evolved? Somebody loses the kinetic energy. Must. Then it's intelligent. Some magnetic phenomena happen. And in magnetic phenomena, if you are losing velocity, where does it go? In heat. So there is some kind of loss of kinetic energy. And heat will evolve due to initial kinetic energy was half mv naught square. Yeah. Only one had the velocity, the second one was at rest. And after a long time, half m v naught by 2 square is the velocity of one of them, and they were 2. So I can multiply this result by 2. And what I got? Half mv naught square minus half minus 1 by 4 mv naught square. That means this much heat is going to be evolved. This is the final answer. Thank you very much for watching. I am going to produce 2 lectures today, 2 more lectures today. These 2 are not lectures, basically problem solving session. But I have to produce a lecture for NEET people on whether it will be the first lecture, and that I am going to produce it today, and then I will have another lecture to produce. So thank you very much for watching.